In this screencast, we'll design a data definition to represent an arbitrary number of cars. We are given a data definition for a car that we can use, so we just need to design a data definition that can represent an arbitrary number of cars. If you remember, the data definition for car is from a previous screencast. Remember that arbitrary doesn't mean large. It means that this data definition needs to be able to represent any number of cars. In other words, no cars, 1 car, 2 cars, 100 cars, any number of cars. Therefore, we need to create a list of cars. This list data definition will look very similar to the one we created for a list of integers. The difference here is that car is a user-defined data type, whereas int is a built-in data type. We will follow the How to Design Data Definitions recipe as usual, and we'll pay particular attention to any changes that are necessary since we're designing a list that contains a user-defined type. The first step in the recipe is the data type definition. In this case, list of car is already a meaningful name for this data type, so we don't need to create a new name. The next step is to write the interpretation. We'll follow our usual pattern for a list data type and say that it's a list of cars. Now we need to write some examples that demonstrate how to form data of this type. I'll write a couple of examples. As usual, I'm going to start with the empty list as the first example. That reminds me that an empty list is, in fact, a list of cars, and that might be helpful for me to remember when I'm designing functions that take a list of cars. For the second example, I'll use 2 cars that were created in the car data definition. I could also create new examples here. So I could create a car that's a Mazda 3. I can either use data examples from previous data definitions, or I can create my own examples. Now it's time to create the template for a 1-argument function that takes data of this type. Remember, we are not designing a function at this point. Instead, we are creating a template that we'll use in function designs in the future. Every time we design a 1-argument function that takes a list of cars, we'll use this template. We'll use our convention fun4LOC, which takes 1 argument, which is a list of cars, and because this is the template, we leave ... for the return type. I'll start typing in the body of the template, but you can also copy it from the data-driven templates page. If this list contained a built-in type, our template would now be complete. But if we go to the data-driven templates page, we'll see that we actually need to use the reference rule here. Now I'm on the data-driven templates page in Canvas, and if I scroll down to the arbitrary size rule, I can see that the template looks like the template that I just wrote. But I also see below that if there's a reference to a non-primitive type, so that means a user-defined type, I need to call the other type's template function. Let's go back to the code. I can see here is where I'm referencing the user-defined type. So I need to wrap C in a call to car's template function, fun4car. What that does is remind me when I'm designing a function that uses this template, I need to think very carefully about whether I need a helper function that takes a car. Now we need to write the template rules that we used. For this data definition, we followed 2 template rules. The template is based on the arbitrary size rule, and as we just saw, it's based on the reference rule. Finally, let's run our code to make sure there aren't any syntax errors. And there is a syntax error. It says name list is not defined, so I forgot to add list to the types that I imported. Now let's run again to make sure we have no more syntax errors. This time we have no syntax errors, so our data definition design is complete.